So what's happening this evening is, as many of you are aware, GovHack is coming up. It's the big annual civic hackathon, which focuses on creative reuses of government data. So we want to help you start thinking about GovHack and some of the tools and techniques that might be useful to you for that weekend. So one of the important parts of analysing data is, of course, to communicate what you've found. So I'll be starting out talking a little bit about some of the principles that's important to bear in mind when you're presenting data visually.
Maybe you can just stand back there.
And then I will be handing over to Olga from ThoughtWorks, who's very kindly going to give you an introduction to Chart.js. And then Steve will be taking over to talk about maps and leaflet. So I thought I'd start out by talking a little bit about what not to do when you want to visualize data. You may be familiar with this subreddit, Data is Ugly, which mocks and or celebrates, depending on how you're feeling about it, particularly outstandingly unhelpful, poorly communicated, or just badly designed instances of data visualization. So I thought we'd look at a few examples from this collection. So to talk a little bit about some of the pitfalls of trying to do too much and be too clever, and a little bit about what not to do when you're presenting data. So let's start out with this example. Now, the first problem there are many problems with this, and you will often hear, yeah, I'm seeing heads up sideways already. You will often hear the pie chart mocked. Pie charts are okay in some circumstances. I will talk about circumstances in which pie charts are okay. 3D pie charts are generally not okay. The problem with a 3D pie chart is the problem with pie charts in general is humans aren't great at estimating angles visually. We can do 180 degrees, we can do 90 degrees, we can probably do thirds, but anything more subtle than that, the difference between 14 degrees and 17 degrees, really hard to tell. So for communicating really granular information, pie charts aren't great. When you put them on an angle, put the chart itself on an angle, you're adding a further level of distortion. So it's now really hard to accurately estimate the angles concerned. When you start popping bits out of your pie chart, that's an extra layer of confusion. And then it is nice that they have provided a legend for this chart, but they've labeled it incorrectly. Even allowing for the angle, I'm reasonably confident that that's not 17%. I would be open to the idea, though, that that might be 52, but this might, in fact, be 52%. So maybe if we move everything down one, I think there's a labeling. I think that was just a typographic error, which has resulted in the labels making absolutely no sense. So labels good. Absolutely label your axes. Provide a key to any color coding that you use, but make sure that the labels are right. Just some of the lessons which we can take away from a chart like this. Now, continuing on with the theme of 3D-ness. Quite difficult, again, to see what's really happening in this chart because it's at this jaunty 3D angle. I recently came across a chart which I'm not allowed to show you because it's in my workplace and I'm not meant to show work data in public, but it was these stacked column graphs which were translucent and kind of and 3D and kind of on an angle, and the whole the whole sort of cumulative effect was a little bit motion sickness inducing, but we can see a similar effect going on here where we have a column graph but at an angle like this. The guy person who submitted it to Reddit suggested that it looked like brass, and I can definitely see where he's coming from there. So as a general rule of thumb, I would suggest avoiding the temptation to do fancy things with angles. We're also at a scale here which is pretty well meaningless. Again, similar to the difficulty of estimating angles in pie charts, we go from 0 to 75, but nothing seems to be more than maybe about 3. So to be able to tell anything that's going on in this chart, you really need to pull it round so that it's straight on and significantly reduce the scale here so that the differences in the readings actually produce a visually meaningful differentiation. Now, this one looks kind of cool, I guess. Some people really hate the color scheme. But again, it's one where it's really difficult to tell what's going on. So what this chart is trying to communicate to us is the number of films produced each year in the US and the rating of those films. So kind of, I guess what it's showing us is that R has got rated films have got bigger and bigger over time, but it's, again, the way the data is presented, it's impossible to tell what the actual proportions are and how many films are involved at any point in time. Because we don't start at 0. We start at this random point in the middle here, which lets us kind of expand out in both directions attractively. But usually when interpreting graphs, we expect it to center around a 0 line. So anything below is going to be negative. And we're obviously, well, I say obviously, I hope we're not talking about negative quantities of films being produced. So that's meaningless. And the way in which it sort of jumps around like this, it's very, and that again with no scale, you get a sort of vague idea of proportion that PG is sort of squeezed along the bottom here and there's not much of it, but we're mostly seeing R and PG-13. But in terms of actually getting any meaningful numeric data out of a visualization like this, it's pretty well impossible. So again, the scales start at 0 and be consistent. So you could absolutely do a graph like this as a stacked column graph, and then you would be able to see the different proportions moving over time. But as it is presenting the data in this format, not so helpful. Finally, this one, which looks to me a little bit like migrating stingrays. So what it's trying to show us, I think, is maths test results in different groups of students. So we have male and female students. We have minority, which I think is an ethnic classifier. I think we're looking at non-whites maybe in these groups. We have a scale along here for the socioeconomic status of the school. We have another scale along here for the socioeconomic status of the student. So within the little graphs, we have like rich students in rich schools up here and poor students in poor schools down here. We're using color to indicate the achievement scores in these tests. And I couldn't work out what these little quadranty things are actually meant to be communicating. As I said, the effect is kind of migrating stingrays to my eye. So this is a case where I think the graph generator has simply got way too enthusiastic and tried to cram much too much information into a single graphic. They're trying to tell us about the different impact of race, of sex, of the wealth of a school, of the wealth of an individual, of something else, all on a maths test. And I know it's really exciting when you've got a really rich data set and there are all these patterns coming out and you want to tell everybody everything all at once. Break it out, have mercy on your audience, present a series of charts which draw out the most important points that you're trying to make, so you don't simply end up producing a confusing mess like this. So when you are designing your charts, you have a range of tools at your disposal and ways of communicating differences. what are some of the ways, things which you can use in a chart to communicate data? So we've got, say, relative size, things which get, lines that go up and down, or in a bubble chart, things that get bigger and smaller, can be a way of indicating changes in your data. You can use color. Color can indicate, you can use it to indicate relative intensities, or you can just use color quite effectively, sometimes to make different areas of your chart visually distinctive. What are some other ways you might, or sort of elements you might introduce to a chart? You're all staring at me. Come on, I'm sure you have opinions. I've never known this group to not have opinions. Size and color are kind of the obvious ones. Yep. Sarah? Sorry to Sarah, isn't it? Sorry? Shading. Yeah, shading. So, yeah, a gradation within color can be how intensely colored it is. So you've got a few different mechanisms at your disposal as a way of communicating information. There are color combat. So think about the different ones which you have access to, but maybe resist the urge to pile on too many all at once. As a basic rule of thumb, it's a really good idea, label your axes, as I have said, really good idea to start at 0. I haven't got any examples to hand, but it's quite a dishonest trick, which you sometimes see in graphs, is to not start at 0, or to present things on wildly different scales. You sometimes see graphs with two vertical axes comparing two different readings, or two different factors. It can make it look as though it can introduce the idea of a correlation falsely, but it can also disguise that, or make a change look much more dramatic than it is. So I think you may have seen, there was a graph that did the rounds, and it was produced by Fox News, and it was about so-called Obamacare. And because they were opposed to the program, they presented a graph to make it look as though the uptake had in fact been extremely small, and they achieved this by presenting a column graph, but not starting it at 0. So you couldn't see, so it looked like there was this sort of tiny group of people who had decided to access the new healthcare benefits. Whereas in fact, if you started it at 0, you could see that the column was actually extremely high. So just by doing tricky things with scale, they were able to obscure the rate of uptake and make it look as though the program had been a failure. So making sure that your scales are clear and consistent, and if you're not starting at 0, there's a damn good reason, and it's very clear that you're not starting at 0, are all important to what I would call honest data visualization. Another thing, because we read left to right, we tend to assume that scales are going to go left to right, particularly time scales. If you're wanting to show change over time, start with the past on this side, and time sort of goes this way into the future is generally how people are going to expect to be able to read a chart. Again, if there's a reason why you're presenting a chart temporally backwards, you're going to need to explain why that is and make sure that it's labeled extremely clearly. Some of the work I do is with modeling sales of tickets to performances, and it's easiest for me to do it on a countdown of numbers of selling days remaining, but it means that I end up with these lines that look as because people tend to buy tickets close to an event, I end up with a curve which looks at first glance as though everybody buys when sales first open, and then it tails off towards as performance date approaches. But in fact, it's the other way around, because 0 doesn't in fact mean tickets go on sale. 0 means performance day. So that's just a thing which is okay, I think. for me to do it work because everybody is used to graphs that look like that. But if I'm presenting to an outside audience, I either need to flip it or explain very carefully that what we're seeing is a countdown to performance day rather than a tailing off of sales. So the last little bit you're going to hear from me this evening was to look at this tool called Power BI. Now, Power BI is put out by Microsoft, and it's a way of building dashboards quite quickly and readily. So you start out with Power BI by importing a data set. You can get all sorts of data into Power BI. So you can use locally stored files. You can also connect it to a server. A lot of what I do is just dumping in CSVs or Excel files. So you add your file. Once Power BI has accepted your file, you start to build what it calls reports. Which gives you, so you have a whole range of options here. These refer to the data which is in the table which Power BI is looking at. So in this particular case, we've got information about date, about performance, about month, about tickets sold. And then you have a whole range of options here, and you can download some additional plugins of the types of visualizations that you want to make. So you can present the information in tables, you can create the dreaded pie graph, you can create different types of column graphs, all just by dragging and dropping the different data fields from here into the filters in order to create charts. Once you've created those, you can start to add them to a dashboard. So this is an example that I created for our customer service team to use at work. So they could present to exec their sort of daily activities. So some of it we've just presented numerically because there's not really a meaningful way to communicate it in a graph. And sometimes tabular is the best way to communicate some data. But here, because we're showing working towards a target, I opted for this kind of speedometer-y type of visualization. So we can see the number of calls incoming is our target. Here, the number of calls answered is the blue colored in line. We have the figure 60 there. And our line of 55 there is the, I think it's 85% answer rate, which is the team's target. So here with emails, we can see 14 incoming, 14 answered, 100% colored in. We answered every email today. A slightly more sophisticated offering, which I didn't make, is the daily sales report. So line charts showing targets and actual makes it quite easy to see that at this point for this production, the daily sales are quite comfortably exceeding the daily targets. Stacking up cumulative sales. These ones are a little bit, there was a lot of debate in the office about these ones, and I'm still not 100% on them. This one is demonstrating target versus achievement. So the black line is achieved, up to what is red is target, and anything beyond is overachievement. So in these cases, well beyond the daily sales targets, but still not quite there on the overall budget. So as I said, I would talk a little bit more about pie charts. Pie charts are fine if you want to show progress towards a whole. Yes.
So just a big question before you move off that.
Yeah.
What are the principles that you had in mind when you decided to lay out the dashboard?
I didn't design this one. I can't, so I can't tell you what the author was particularly, what guided his decisions. But I think by putting things like totals up the top there, and then the performance against targets in the middle, I think it's trying to put the most important information sort of top and center so that it's easily accessible, and then moving down to that sort of bottom right corner, which is perhaps not the first place you look on the screen, so information which is not quite as important. But I can't swear to the exact reasoning behind that. So yeah, these are occasions in which I think a pie chart is forgivable. When you're showing progress towards a whole, it's really important that when you're presenting a pie chart, it's something which adds to 100%. Does that make sense? If we're showing a series of change over time, a pie chart isn't going to help you. But if you want to show proportions of a whole, a pie chart can work. But I feel it's important that you only use, only if it's a few categories. Yeah, once you start to get lots and lots of really tiny slices of your pie, they cease to really be a useful means of communicating information. So those are at least some of my opinions on trying to communicate information clearly in visual form. So I will hand over now to Olga, who is going to show you a bit about how to make some graphs and visualizations of your own using Chart.js.
Thank you, Fiona. And so full disclosure, I am a developer by trade. I don't do all that much with the data analysis, but I know how to build charts and websites. So today I'm going to talk about the Chart.js. Chart.js, essentially, why I picked this, because there are multiple technologies to do front-end UI, HTML, chart loading, preloading, populating, making it pretty and amazing. And one of the most popular ones are something like D3. From my perspective, I did work with D3 and I found it a bit convoluted because documentation is, well, insufficient and not very descriptive from my perspective. I like clear, concise ideas of what do I need to do to make it work. Otherwise, I would be bashing my head against the wall or trying to debug what's happening on the front end. So I thought it would be good for an audience that might not necessarily, and I'm not saying that it's you. If it is you, that's absolutely amazing. If it's not you, then sorry about that. To show an option that is not as involved and is easy to understand, and it also has really good documentation, which is quite important when you're learning something new, in technology especially. So I found this Chart.js library. It's essentially, what is Chart.js? It's simple, clean, and engaging HTML5 based JavaScript charts. They allow you to do some animation, some interaction graphs. They do some responsive designs to put you on your mobile, on a tablet, on a computer, whatever you prefer. And again, it has awesome docos. You can go and find out a bit more about this particular library at chartjs.org. I'm going to show you the website in a bit. One full disclosure here is I'm not going to teach you right now how to do Chart.js. Documentation is fairly clear, so you can go and try to play with it. If you do wish to do so and you run into problems, I'm more than happy to answer the questions or help you out to figure out what the hell went wrong. However, right now I'm just going to show you the possibilities and why I think it's simple. Again, simple you say. Let us see. Whenever you're working with Chart.js, you start with a simple HTML5 document. So you have your doc type, HTML, you have your HTML tag open close, you have your head, and the most important part in the head is that you import your Chart.js library. You can import it either from the using the direct link online, or in this particular case, I downloaded it into the Chart.js folder under my project, which is a folder where this file is located, and put it in there and refer it directly from there. And the most important part here is a body as well. And here you have two things that you need to pay attention to. You have your canvas with ID that you're referring to. This ID is important. You're going to be looking at it afterwards. And this is where Chart.js is going to be populated in. Canvas, essentially in HTML, for those who are not very techy, is the stuff where you load your images into, or your graphs, or your any visual or any content that is visual, essentially. Not necessarily text or anything like that, but any videos, whatever. And the important part here as well is you then add your script with the reference to the Chart.js app, which is app.js. Essentially, it's just a file that contains all of your Chart.js configurations, and I will show you it in a minute. So this is your app.js. This is all you need to load. Oh, you don't see the little thing. Sorry. This is all you need to load a chart in your file. So in your website, in your HTML document. So one of the main things here that is limiting in Chart.js is that you have to have a specific data format. And I wouldn't pay too much attention right now at it because they document it quite well. For each of the charts, they have different type of the different format of the data that it should be in. But in this particular case, it happens to be that it has to have data sets, it has to have labels, and the data sets correspond to contain data. This is the most important part. Each of the data items correspond to the label in the data set, and then you plot it. So in this particular case, I am creating a new chart, which is a line chart. And I am, saying that this particular line chart based on my data set is going to have 2 lines. To create a new chart, new line, you can follow 2 approaches. In this particular case, I chose to go the old school way. That's one of the ways to do this. And essentially, I'm saying get a document. Get a document means refers to get the entire HTML file. Find an element by ID. This is the canvas chart. And if you refer to the previous page, this is your ID. And get a context 2D. Get context 2D is a requirement by Chart.js. It just says you're going to render 2D context, 2D information in it, not 3D, not anything else. And the next line I'm saying, I want to create a new chart, and that comes from your Chart.js library, which is this line of code. And I want to create it in the context that you just created in a line before. And I'm saying what kind of a chart I want. In this particular case, it's a line chart. Providing the data for it, which is whatever information I supplied before, and the options for it. Options, again, are very well documented on the website, so you can play with it. It's your responsive design, your colors, your, not quite sure, there is a whole bunch of them. So essentially, once you load your index.html, you will come up with this. That would be about, 30, 40 lines that you need to type in to achieve this with your data. Yes, there is a draw side. You need to mash your data in the format that Chart.js expects you to do, to have it in, but you would need to do this as well in D3. So to a certain extent, you can play with it, but in a grand scale. What do you follow? What do you do whenever you're creating a new Chart.js thing, Chart.js project, if you follow the IT-ish way of thinking, is you create a new folder where you're going to put all of your stuff. You download your Chart.js from this particular location, stick it in there. You create your index.html file, which is looking something like this. And Chart.js gives you an example of it. You create your app.js file, which looks something like this. And again, Chart.js provides you an example of it if you want to play with it. And you open your file using the web browser. You can host it if you want. There are multiple ways of hosting your applications, and one of the cheapest ways from my perspective is to use something like Heroku. Heroku is free for the majority of applications. You can extend it if you want to use databases and stuff like that, but in this particular case, you probably won't, and host it there. And again, Heroku has good description of how to host things on it as well. All of it is very well documented and clearly described. So Chart.js website essentially looks like this. You can do the whole bunch of neat and nice things with this. And again, one of the most selling points for me personally was that I go into the documentation, which is this giant big button, and it gives me a configuration to set up each of the charts with a description of what you'd expect it to do and how it wants you to go around to do that. So if you know some tech, but you're not really that technical, this is a great place to start. Another thing, it contains the whole bunch of information, and it contains the whole bunch of different approaches to do different graphs. And I mashed up a quick and dirty page with 3 graphs in them. This is the real data, but population. Sorry, nobody told me the last time I was running it. So the population growth in Victoria by sex. This is the real data coming from the data.gov.au. There is a bar chart, which is the mashed up data, and there is the Fiona's favorite pie chart.
You see 3 colors, only,
It's proportional information. It's not about data, it's about proportions. And it's 2D.
Yep.
So how it looks from the code perspective is that you have your, I chose to split it around in between 3 files. You have your simple index.html, and here the important bits are, I'm including Chart.js and data.js. jQuery is another library, and if you want to be a bit more fancy, you can use it. You don't have to. And I'm saying that I'm having 3 canvases where I'm populating my charts, and each of the canvas has different ID or class depending on what you want to use. In the data perspective, it's just a mash of all of the information. Again, I mentioned that this data is from the data.gov.au. The one thing that I've done is just mashed it in the format that Chart.js wants me to have it in, and that's about it. Didn't do anything with it. The second thing is just the dummy data from what it wanted me to have. So in the majority of cases, like data chart and the line charts, the data sets formats are similar, and that's primarily why I chose these particular 2 approaches. The pie chart, on the other hand, has quite a different way of representing the data. So you might use the same mechanism to pass your data into the line chart and bar chart formats, but for the pie chart, you need to play around with it a bit more and have a different way of presenting it. And in your app.js, I have 27 lines of code to load the thing. Again, as I mentioned, you can use the old school format of document.getDevelopmentById line chart to get your canvas to populate the Chart.js stuff in. The jQuery, the reason why I added it is you can do the same thing using jQuery. Again, that's a more fancy approach. You don't have to follow it. And you can also, and the way that all of the charts are generated is in exactly the same way. You create a new chart, you provide your context, and you set up what type of a chart it should be, bar, pie, online by supplying the data to it and the options. Again, the options that you're supplying are specific to each of the chart types and are listed in the documentation. I know that I just glanced through the whole thing, and I'm not expecting you to learn and know it in just literally 10 minutes that I gave you in this information in. However, I do urge you to come and play around, even if you're not technical. The last time that we were running this, we had a whole bunch of people doing a dojo, essentially sitting in a room and trying to hack at it. And everybody achieved results. Everybody went through the entire dojo, and it's achievable. It's not rocket science. You can figure it out. Play with it. And if you have troubles, come and see me. I'm here every Wednesday. Thank you so much for your attention, and I'm going to pass on to Steve.
Can I ask one question first? What are the major limitations of Chart?
It's not like D3 where you can add your own animations and functionality. In Chart.js, you have to follow the way that they ask you to do stuff. So for the majority of developers, whenever you're playing with this, you would think you would use this for representing simple information. But if you want to have some wow effect with like extremely amazing animation and just crazy stuff going on, you would probably use D3 because you can make it do whatever you want, essentially. Any more questions? Thank you.
Wow, most seamless transition ever. It's a little bit sad that the URL is cut off at the bottom. Will I worry about it? Anyway.
What is it, Steve?
What is it? The URL is bit.ly/okdvis1. So I could talk for about 3 or 4 hours here. How long do I want? 20 minutes? Half an hour?
It's 5 to 7.
Okay, maybe I'll go for about 40 minutes. Okay, so we've been talking about data visualizations, which is when you get data and then you turn it into graphical, pretty stuff. Visualization of trees and how many of different species there are in the city of Melbourne. Thing is, if your data has some sort of geographical component, you can start to do visualizations that incorporate geography, location. So in this case, I'm visualizing the number of trees of different species, not just how many there are, but by the precinct. So these trees have a precinct attribute on each of them. So in a sense, this is a geographical visualization, but probably most of us would not call that a map, right? Even though it has, it tells you how many trees are in North Melbourne or Kensington or whatever. But if we plot a latitude directly as part of our visualization, then, so that's the column on the left-hand side, 37 degrees south versus species. Now I've got something which is even more geographical, probably most of us still wouldn't call that a map. And then if we do a scatter plot of latitude versus longitude and get it wrong, then we get that. And that's kind of a map, except it's basically sideways. Well, it's kind of flipped. This is just basically a really long segue from data visualizations to maps. And if we do a scatter plot and we get the latitude and longitude run the right way, then now we've got something that many of us would call a map. But it's not a map, it's actually just a data visualization. Because data visualization is a map. A map is a data visualization, just a special form of them. And there, what am I doing? I'm plotting types of trees as shown by color and location shown by location. What does this data viz tell us? Tells us that there are lots of gum trees in Royal Park. In sight. That's what it is in sight for us. This one, on the other hand, shows us where to avoid if you are allergic to the London plane tree. Short answer, move to Adelaide. Actually, Adelaide's probably also bad. Maybe move to, I don't know, the country somewhere. So that's just a really simple data visualization. Everything that is a London plane tree is a big nasty red color. All other trees are green. It's amazing how many people I talk to about maps, and people say, "Oh, I love maps. I've always loved looking at maps." Why do people love maps? Well, here's my hypothesis about why everyone loves maps. Because every map is related. So if you take two random data sets, there is not necessarily any relationship between them. But any two maps, they're of the same place, there is a relationship between those two things. So you could mash up a data set of location of hipster bars and another one of location of casuarinas, and you can put those two things together, and there is a relationship between them, and you can see whether hipster bars are correlated with nearby casuarinas or not. Maybe they are. Also, everyone knows where they live, everyone knows where they work, everyone has some sort of point of reference. So people kind of connect personally with maps because they can show people something on a map, and straight away they'll look up where they are, their home on the map. For those who haven't read every single XKCD, this is a fun one, showing the pitfalls of getting too excited about data visualizations in form of maps. In case you can't read it, what it's basically showing is 3 different kind of heat maps of data shown on the map of the US. On top left, our site's users. On top right, subscribers to Martha Stewart Living. And the bottom left is consumers of furry pornography. And the trouble is when you just plot data sets like that in raw form, they all basically look the same because all 3 of those things are correlated with population. So in centres of high population, you'll have more consumers of furry pornography and more subscribers to Martha Stewart Living. And it's amazing how often you see this mistake on maps across the web. Because just the first thing that people do is say, we've got some data, it's geographical, let's just show it on a map. And what you really just see is where people live. Because whatever it is that people are doing is very, very strongly correlated with where people live. So if you want to make a map visualization, just don't do that. Don't just draw points on a map and don't just go straight for the heat map, because you're probably not showing anything interesting at all. You really need to relate it to population or something. Are there more consumers of furry pornography there than, I don't know, types of other pornography? Okay, so I think it's time we did a little bit of hands-on. I just removed the exercise, which is on the left-hand side here. If we're going to make a map, we're going to need some spatial data. Best place to find spatial data is nationalmap.gov.au. So for those of you with laptops, I would suggest spending 5 minutes on nationalmap.gov.au and find an interesting data set. For those without laptops, you've now got an opportunity to find a friend who has a laptop. Hello. The Wi-Fi details are on this wall over here. It's a really long password. I can't. It's oh god, yeah, it's horrible. Draw Monty Autumn Blythe Coach with spaces. Obligatory disclosure, nationalmap.gov.au, working on that is actually my day job. So it's really good. So there's data on there at federal government level, state government level, local councils. So the people that are looking at me, is that because you don't have Wi-Fi or? Oh. Okay, who does have Wi-Fi? Oh. Rightio. All right, I will just walk through a little demo for those that can't play along at home. So when you go to national map, then you can see national data sets which have things like availability of broadband in different areas. Or we can see, I don't know, where are some islands, lots of different spatial data sets. Is that the islands one there? But also what's cool is it pulls in all these spatial data sets from data.gov.au. So if you were living in Geelong, then you could find accessible amenities. So we'll turn that one on. And I might just go and turn off that previous layer. So I've clicked on an accessible amenity and it says type is toilet. And this one is a disabled parking in Geelong. What else can we find in Geelong? Locations of barbecues. There's an electric barbecue. Has anyone found the data set they want to tell anyone about?
Cemetery areas.
Cemetery areas. Is that in Geelong or is that just a national one? Cool. It's not really habitation, is it? Well, get turned on cemetery points. Any other data sets that anyone has that they want to talk about?
Surface geology under land.
Surface geology under land. Yeah, that's quite a pretty one. Now, for those that don't have a mapping background, I'm going to vastly simplify the entire world of GIS, which is Geographical Information Systems, and say there are essentially two kinds of mapping data that we could be working with here. So what we're looking at there is basically a pre-rendered map image of surface geology. So it's got information baked into it that, that tells us that green means whatever that is, Cretaceous sedimentary rocks. And that's kind of nice to look at, but not very useful to us if we want to build our own data visualization, because basically it's like you've already got a picture of a thing, you don't have the thing itself. And then the other kind of data is what's often called vector data, is when you have sort of raw data elements and then you can apply your own styling to them. So I'm going to cheat a little bit and see if we can find some of that kind of stuff and do a little filter. Is GeoJSON. Hopefully it's going to turn me up something which is a GeoJSON file which we can then go and style. Okay, so it's found something for me from City of Melbourne. Syringe bins. Actually, is that City of Melbourne? Yes, City of Melbourne. So there, you can kind of get a sense by the different way that it's visualized here as these little circles. We actually have raw data that we can go and play with. Don't know if it's going to be super exciting, but let's do something with that. Okay, so I'm going to click on the little I button. Now I can go to the GeoJSON. Sorry? Well, what do you want me to do about that then? It's making a lot of noise, like it might start up again. Okay, so that thing there, it's given us an actual URL of the raw data. So I can now go and download that thing. And that is what that data set looks like. So it's basically the locations of the syringe bins around the city of Melbourne. Suspect this is going to be a really dull visualization, but you know, it is what it is. Okay, so now that I've got the URL, in fact, I don't even need to download it, I'm going to introduce you to a tool for making visualizations out of map data. And this tool is CartoDB, cartodb.com, and it's kind of free-ish. Unfortunately, the way the screen is coming out. So I'm going to sorry, something's a bit strange about the way this is working. Okay, so I'll go new map. Actually, in fact, just to make this work a little bit better, instead of using the GeoJSON file I just found, I'll use a different one that I got from a different site. It's slightly more interesting. This is from VicRoads, and so the basic workflow is the same, except that the data is slightly more interesting. So this data set is of bridge structures around Victoria, which I found on VicRoads' open data portal. And when I click on a point, so if I go to the data view, we can look at the attributes in that data set, and it has things like bridge type and sort of codes, and it's even got some numeric fields somewhere, which is like the length, yeah, the height of cell, whatever that means. Lots and lots of attributes, so we can turn those into some sort of visualization. So the simplest visualization you can do is make everything look the same. Just show you the points, which is what we've got there, orange circles everywhere. That's kind of dull. So we'll go to a wizard thing over here, and let's have a category visualization. So this is a pretty simple thing to understand. We're basically color coding some sort of attribute. And the attribute we'll use here, let's go for that bridge type that I saw before. Bridge type. Normally CartoDB doesn't look quite so squished down like this, it's just the projector. Okay, so straight away we've got a color-coded visualization with some, we've got pedestrian overpasses and pedestrian underpasses and road over floodplains and stock underpasses and all that kind of stuff. We could do a choropleth, which is using color not to just color code distinct categories of things, but to take some sort of numeric attribute and then use a color range to convey the values in that attribute. So if we take that height of cell thing and make that the attribute that we're color coding on, then you kind of get the idea. That yellow means not very much height of cell, and dark red means very, very much height of cell. Adrian, do you have any idea what height of cell means? No. Do you know what any of these other ones mean? Oh, overall length, I think we can understand that one. Cool. All right, so now we have a visualization of where the longest bridges in Victoria are. To make this visualization more interesting, maybe let's try filtering out some of the short ones. Well, it's kind of hard with. Okay, that's better. If we use this filter on, what was it called, overall length? And put it filter up. But hopefully this will reduce the amount of data. All right, quite possibly I should have done more homework before I came. Anyway, another visualization type we can do is do bubbles, make things bigger depending on what is being. Let's have overall width, so wider bridges are bigger circles. And then once we've made our visualization, which is probably a excessively polite way of describing what we've made there, we can go publish, we grab a link, and I can go and share that with somebody else. So in the context of GovHack, CartoDB is a really, really good way of saving yourself a lot of time. If you think you might want to make some sort of map, you could spend a lot of time, say, learning Leaflet or a different tool if you've never made maps before. Or honestly, you could load your data into CartoDB, do some quick color coding, and in an hour or something, you'll have something like this. And then you could also take that the thing and just embed it. So there's an iframe link ready to go, whack it in the middle of some other website that you built, and okay, presto, instant map-based visualization. That's the question.
Yeah, I just noticed earlier there was a thing down the bottom suggesting some of the supposedly interesting maps that they discovered out of the data.
Yeah. So.
Can you try that, and what do you think?
Yeah, so CartoDB has this feature where it sort of analyzes your data set and then tries to guess what might be a useful map to make out of it. So it sort of looks at numeric fields, and for a numeric field, it'll suggest a choropleth, and for a category-based, like for a sort of a category field, it'll suggest a color-coded visualization. I've never played with it very much because I tend to want to, explore the data on my own. But it's probably a useful way to get started. Yes.
It's the height of the cell of the culvert in meters. The culvert is the underpass underneath the line. So what height should it really tell you?
Right, okay. So if you have like a sort of a drain under a road, then it's like how big that drain is. Okay. Yes?
Yeah, just wondering what happens if you don't have the audience, you only have the street address of your data?
That is a very good question. So if you have some sort of data set with addresses in it, and they have not provided you latitudes and longitudes, then what you can use is the CartoDB geocoder. So that's the process that you need to go through. It's called geocoding, which is turning some sort of address information, a description of a place, into a numeric location, so a latitude and longitude. This data set doesn't have that, but all right. Imagine we were using this column here, which is sort of a description in some places. In CartoDB, we could actually say georeference. So we'd click on that, and then we would say that the things we have there are street addresses, and provide some attributes, and it will actually go and attempt to turn those into locations for us. And there are various services around that do this, and as long as you only have a couple of hundred points, it's generally free. It gets expensive if you have a lot of points. You can, of course, visualize things that aren't points, such as lines and shapes and so on, but I'm giving a really high-level kind of overview here.
Can you reverse that? Reverse geocoding?
Yes, and that process is called reverse geocoding. It really is. So reverse geocoding normally comes up in the context of like a mobile app or something that's trying to tell you where you are. So it knows your numerical location, very precise latitude and longitude. But what you want to know is, oh, you're kind of on the corner of Smith Street and Gertrude Street or something. Doesn't happen so much in the context of just building a map. I don't even know what tools I would recommend for that exactly, but you know, Google Maps has an API, Bing Maps has an API for that kind of thing. Other questions? Cool. I might jump back into my preso. Now, I might just show a couple of examples of the kinds of things that you could do in a GovHack project using spatial data. So here's one that I did two GovHacks ago. This data, this was a data set from Transport Safety Victoria with the waterway regulations. So it's quite a big data set of lots of information, like in this particular patch of water, there is a speed restriction of 10 knots, and in this patch of water, jet skis are prohibited, and in this other area, it's reserved for swimmers. And I just took that data and did a super simple, like assigned colors to some of these broad categories, rendered a very simple map, and submitted it, and won a little prize. And I think I might have finally let that domain go this month. Can I go there.com? This was a much more serious GovHack project. We did this the same year. So those yellow circles are like the number of pedestrians out and about, because the City of Melbourne has live pedestrian counters, which is pretty cool. It's based on infrared scanners. And the orange circles are the locations of the bike hire scheme. So it'll tell you how many bikes are available in each of the different stations. And then sort of we combine it with some other information about like how long it would take you to get home from somewhere by train. Oh, and the little green fuzziness all over the city, that's actually their tree data set again. This wasn't a GovHack project, but here I mashed up the building footprint data, which comes from the City of Melbourne, with a different data set that showed which, basically where construction was happening in the city over the next 5 or 10 years. And by assigning a different color to each year in which a project would be happening, it kind of gives you a sort of a snapshot glance. Much more useful if you had the legend. Talk about a massive data visualization fail right here. From memory, black meant like a really long time in the future, and yellow was, okay, this is actually a really bad example of the data visualization. I did this a little bit quickly. Here was one that I did. I was helping Matt, who keeps running in and out. This is wheelchair sort of accessibility visualization. So what it is, it's footpath gradients. City of Melbourne provided this data in very sort of fine-grained detail, like the precise gradient of every point of footpath around the city, and they've done some analysis to automatically generate this from LiDAR data that is captured by cameras mounted on planes that fly overhead. And then to make it much more useful, I looked up the sort of regulations for recommended maximum wheelchair gradients for motorized, unmotorized wheelchairs, and where it's just 2 seat altogether, and just reduce the map down to those 3 colors. So rather than, I mean, actually by throwing away information, by throwing away all those fine details, it actually makes the map more useful, because you can just instantly see all of green is fine, yellow is only okay for motorized wheelchairs, and red is just too much. So kind of by combining precise data with regulations, you end up with a more useful data set. And this was made as an overlay for a different map. And this is one that someone made, again, from that tree data set, showing they combined the sort of date that these trees were planted and their average lifespan to work out when they hoped that all the London plane trees would die out in the City of Melbourne, assuming that they weren't replaced, which they probably will be. And then other people have made maps of, well, actually that was pretty complicated, but this is taking a Vic Roads crash stat data set to try to predict which route through the city would be the safest by avoiding places where many crashes are known to have happened. And here was another GovHack project by Yuri Feldman. just a pretty visualization of the age of buildings in Geelong. And so there's this building footprint data, and I think it was published primarily as a sort of a useful reference to just know where all the buildings are. But because it had the date that each of those buildings was constructed, you sort of turn that into an age, and then just do this visualization to see kind of like the history of Geelong over the decades. I'll just skip a couple, and yeah, maybe I'll just show this one and then kind of leave it there. This was a GovHack project I did 3 years ago. I took the immigration and asylum seeker statistics from Department of Immigration and Citizenship. I don't know what it's doing. It's not very up there. What? I don't know what is going on. Yeah, so the visualization here is trying to make sense of this these sort of statistical data sets of how many refugees, how many asylum seekers, how many migrants are each year to Australia, and actually turning that into spatial data by using the origin country for each of those people arriving. So the visualization here represents each person as one point, and then you can actually see them move. And they're color coded. So red are people arriving through the normal migration stream. Blue are people, boat people arriving as irregular maritime arrivals, and then green are people arriving as through the sort of official refugee channels, basically being transported directly. So the idea was to sort of try to show the proportions of all of these things. Cool. Shall we take a little break of some kind?
Yeah.